We have also covered the algorithm of MySort. Here we have received an array and starting index of the array, which is referred as P, and ending index of the array, which is referred as R. P and R, starting and ending indexes of the array, and we just check whether P is less than R, and if it is true, we just divide the array into half. So this half is actually referred as Q. So if this is P, start of the array, if this is Q, end of the array, so we have, sorry, R, this is R, let me erase it. This is R is the end of the array, and we have somewhere in the center of the array, this index is actually referred as Q. Okay, these are the indexes. Just keep in your mind, these are the indexes, not the values of the array. This is the indexes. P is the starting index, R is the ending index, and Q is an index which is actually referring towards the center of the array. We just recall this merge sort function with half of the array first, array starting from P to Q, and half of the array second time, array starting from Q plus 1 to R. The first part is passed to the merge sort, and then the second part is passed to the merge sort. And when we just perform the combining process, for that purpose, we use an algorithm, a sub algorithm, I should say. This is your main algorithm. MySort is your main algorithm, and this merge is actually part of this large algorithm, sub function, subroutine, or you can also call it sub algorithm. It takes an array, A, starting index, middle index, and ending index. And what this sub algorithm will do, it will just combine these two arrays. And how these arrays are actually identified, P to Q is one part of the array, Q plus 1 R is the second part of the array, and these two arrays will be combined and merged into a single array. It will actually take two sorted arrays and combine them into a single sorted array. Basically recursive calls. It means that this function is going to be executed many times, just like iterations are going to be executed many times, and it means that this activity of merge will be performed many times, as this function will call itself. This merge activity will be performed not once, it actually performed many times. As many function calls we have, the merge function will be called again and again. And if you just observe how many times this merge function call for this situation, so every time we will combine arrays, it means that this merge function will be called here. Again here, again here it will be called, here it will be called. And again at this point, the merge function will be called, and at this point, merge function will be called. And finally, at this point, merge function will be called. Because we have multiple function calls, it means that this merge activity will be performed again and again. And what this merge activity will do, it will take one sorted array, let's say this one, and another sorted array, let's say this one. How it will differentiate between these arrays? It knows that this array consists of P to Q, and this array consists of Q plus 1 to R. It actually part of one array but divided into multiple parts. So what it will do, it will take an array which consists of P to Q and another array which consists of Q plus 1 and 2R and combine them into a single sorted array. These two sub-arrays are actually already sorted, but what the merge activity it will do, it will combine these sub-arrays and now reunite them into a single sorted array. So the merge activity will take two sorted arrays and combine them into a single sorted array. This is the job of this merge activity, which is actually performed again and again in this algorithm of merge. Again and again means that because we have so many function calls, and on every function call this merge activity will be performed. So this is the algorithm of this merge activity. You can quickly observe the input of the algorithm, array, starting index, middle index, and the ending index. We need 3 indexes for the merge activity. We have 2 arrays, 2 sub-arrays, and one sub-array consists of P to Q, and other sub-array consists of Q plus 1 to R. In the beginning of this algorithm, we will take another array. If I can show you this activity line by line quickly and then explain this algorithm. So at the beginning, we will take an array with the name B. So just to sort, combine two arrays, let's say this is one array, this is the second array, let's call it A. We want to combine A and C. This is C. We just want to combine A and C. Okay. This is A, the first array, and this is the second array, and we want to combine them. And what the algorithm will do, it will take another array with the name B. So the size of B, you can observe that is P to R. It means that the size of array B is equal to the size of array A plus size of array C. So we have another array, third array, let's call it a third array, and it consists of, or it has a size equal to the size of A and C. So after that, we have taken some indexes. If you just want to observe these indexes are actually resided on these arrays. For example, K is now the starting index of B. I, you will see that in the later part is starting index of A, and K is starting index of C. Okay, after that we have written a loop. This is a loop starting from line number 4 to 7. What we will do in this loop, we just compare the first item of array A with the first item of array C. Okay, you can observe that we are comparing first item of array A and first item of array C. They are actually part of the same array, which is divided into two parts, which I've already told. Now, if the condition is true, it means that it will put this item into array B. If A of I is less, it will be transferred into the array B. If the other item is less, mean A of C, if this item is less, it will be transferred in the array B. So it is written here in if else part. If condition is true, it means that this item is transferred in the B. If this condition is false, it means this item is less, it will be transferred in the array B. So it will just keep on doing this activity. It will just comparing the items one by one, and the item which is small, it is transferred inside the array B, and only the index I will be shifted on the next level if a of I is less, and if a of j is less, only the j index will be transferred on the next level. This is you can also observe from this loop. I will be transferred on the next line if it item is less, and if j item is less, it will be transferred on the next level. J is actually here. This let me correct this one. J is actually on the second part of the array. K is here with B, and this is how these indexes are actually placed on these arrays. Now it just keep on doing this activity. Now after this loop, there is a possibility that maybe some items are remained in the A part of the array, and there is also possibility that some items will remain in array C. It is possible that maybe some items are left in the A array, and maybe some items are left in the C array. It's not possible that some items are left both in the A part or in the C part. One array may have some elements, and we need to have two loops to make sure that if some of the items are left, they will be transferred into the B array. You can observe that first we are testing that if some items are left, I less than is equal to Q, it means that this is here we have the Q, and if I just keep on advancing and I is currently here, it means that I is less than Q. Some items are left in the A part, and if I is actually here, it means that no item is left in the one item is actually left here. If I is actually one step away than Q, it means that no item is left in the A part of the array. And if the items are left in these array, we will transfer these items into the B array, which is our finally merged sorted version of the array. So you can observe that this loop will maximum execute n over 2 times, and this loop will also maximum execute n over 2 times, and only one of these two loops will be executed. It's not possible that both of these loops will be executed. Only one of these two loops will be executed. And after that we have another loop, and this loop will simply transfer all the items which are sorted and merged into this array of A. It will simply transfer all the items into the array A, because our final array is A array which we want to sort, and simply we transfer all the items from B into the A. Now this is the merge activity. You can also observe this activity from this simple animation. First, you can observe that we have compared array 2 with 3, A of I with A of J. 2 is small and 2 is transferred in B, and index of I is one step forwarded. You can observe from the next citation. Now we will compare 5 with 3. 3 is less. It means that 3 will be transferred in B. Okay, and index J is now transferred one step further. You can observe here only the index I will be moved, I plus plus, or index J will be moved, not the both indexes will be moved. This activity will be further performed. 5 will be compared with 10. 5 is small, it is transferred in B, and index I will be one step moved, and 7 will be compared with 10 now, and 7 is transferred in B. And after that, 9 is transferred. 9 is compared with here and with 10, and 9 is transferred on B. You can observe that, and now you can see that I index will be moved here. Okay, this upper loop will be stopped, terminated, because it has two termination criterias. One is not fulfilled, and it means that the upper loop will be stop working now, and we will have to shift on the next two loops. And now you can observe that one array is completely transferred in B, but some part of the other array still has some elements. Now what we want to do, simply transfer these elements into B array. We need not sort them because they are already sorted. And now we simply transfer these elements in the B array. And that is why we have written these two loops, simply transferring elements into the B array. So these loops will simply transfer elements, and after that all the elements of B array will be transferred into the A array. Okay, this is the working of the merge sort. Any question?